So I welcome you all to the second session of today. And in this session, Professor DEBABRATA Samanta is our research person. So I would like to say, Abhishek, kindly give the brief introduction of Professor Samanta.
Sir, good evening, everyone. It's given me immense pleasure to extend a very warm welcome to our distinguished speaker, Dr. Samanta, Program Head and Assistant Professor at the Department of Computing and Information Technologies at RIT Kosovo, Rochester Institute of Technology, RIT Global Campus, Europe. Dr. Samanta is an accomplished academician and researcher with a PhD in Computer Science and Engineering from the National Institute of Technology, Durgapur, India. Specializing in SAR image processing, he had made significant contribution in diverse areas, including image analysis, video surveillance, deep learning, blockchain, satellite, statistical modeling, wireless ad hoc networks, and neural language processing. He had completed multiple consultancy projects, guided PhD scholar, and secured international research funding. With an outstanding record of over 260 publications, 22 patents, 13 authorized books, 22 co-edited books, and several best papers. Dr. Samantha is a globally recognized academician. He has also been associated with reputed publishers such as Springer, Wiley, CRC, and Elsevier as an editor and reviewer. Beyond research, Dr. Samantha has actively contributed to the academic community as a convener, keynote speaker, session chair, board, advisory board member, and technical program committee member in numerous prestigious conferences. We are truly honored to have such an esteemed personality with us today, and we look forward gaining valuable insights from his expertise and experience. On behalf of the organizing committee, faculty members, and participants, I extend a heartfelt welcome to Dr. Samantha. We are grateful to you for joining us and sharing your knowledge in the FDP program. The session is yours, sir. Sir, you muted your voice.
Audible, sir.
Yes, hope am I audible now?
Yes, sir.
I think
Yes, sir.
someone is changing my control. Okay, no problem. We'll manage this. Just give me 1 minute to share everything. Yes, good evening all. Basically my place is afternoon, noon, just like a different time zone. It's happy to be part of this prestigious FDP and the n number of audience. I really appreciate to the organizer to gather this different kind of regions, all the participants. Basically 1.5 hours we will do some hands-on session, some real-time practical based work, because in European environment we need to be create some product than the other work. Basically most of the work we can follow up by the publication base, or we have to create some activity in the part of the different presentations. But in our environment we have to create the product, we have to create that actual application in the field of this. So today I will project my ongoing 4 applications in the medical sectors, where that deep learning and the machine learning, they can give slightly better activity and the output in the terms of medical sectors. Thank you, professors, to introduce myself. this is, I don't want to spend much time. Depends on that they can get all the informations previously. I am the first Indian who worked at RIT Kosovo. So Prime Minister gave me that award. Apart from that, Kosovo, North Macedonia, Austria, Germany, Finland, Brazil, and Morocco, we have some research centers. US government, they are using my algorithms in their cyber process in the medical sector. So I received the medical badge from there. In India, IIT Kharagpur and the NIT Raulkela, I have my research collaboration in the part of different kind of deep learning process. This is my current stage is more than 7 months is snowfall. It's very difficult to manage the real-time activity in outside the campus. That is most of the European environment, they want to continue their activity from the home, like the COVID situation. So obviously, if you want to manage, if you want to control everything, so obviously we need some algorithms who can predict a better way in the terms of long distance process. It's not the 5G, it's not the part of the remote control, but we need a strong algorithm to manage something real time data set in the terms of everyday activity. This is my team of some of the UG students, postdoc students, and few master students and the faculty members. We are trying to solve the societal problems in Kosovo or Balkan region in this part of the European environment. And we don't have any exactly syllabus, we don't have any assignment or the exam based process. Every year the students, they have to be create one real time project, and they have to sell the company. If the company purchase the product, the students eligible to go the next level. So this is the work process. So that is the way to execute our uh, daily life in the terms of different way. Now we come out to the topics as we focus on these medical sectors, machine learning, deep learning, and the part of the few medicine sectors, how that upcoming traditions is going on. Hope you got the news that this all over world, the Balkan region or the small country, the Albania, they first launched the AI minister. So because day by day, the all over world, the huge corruptions in introducing the part of the ministry level. So in the first on the country, they launched the minister as a AI. So that means AI sector have a huge demand day by day in the terms of different production process. Today I'll project it only the terms of the medical sectors, and we can create the different kind of predictions that give you the uh, highest accuracy level in the terms of societal impact process. Is a common questions why you always select the deep learning, why you want to always select the machine learning or the next level that computer cells AI process. And some people they are move on in the expendable AI process also day by day. But the question is, with some data we can create, and then we can go for the prediction model. So if you follow these basic steps, automatically we can create our daily life problem statements in European environment. As you know that 7 months snowfall, that means it's very difficult to direct heat to the sunlight to the skin. So that means the huge uh, process of the skin cancer in entire European environment. So always we tested the first algorithms, is it suitable for that cancer detections or not, skin cancer detection or not. So this is the way we can train the algorithms and go for the next level. Sometimes we execute in the terms of different kind of survival process, that how these algorithms existing process or previous medicine treatment techniques they can support in the upcoming trends. So that also we can give a different kind of prediction model. Hope you know in the times of the COVID, lot of different kind of training tested algorithms, medicines process invented. And suddenly the Russia also want to be launch the first cancer vaccinations process. Is a huge revolution happen in the terms of this kind of prediction model and testing and tested process in the terms of different kind of medical sectors. Yes, we have a huge challenges. First thing is that every country, they have different kind of law of medical sectors. They have different kind of sensitive data accessibility is the very difficult process. So what we are doing, we are creating a model in Balkan regions, European environment, but I have to be sent in India, Nimen's Hospital, Bangalore, to test, to got the approval process. So it's a very complicated process, and day by day that the every country, they have the law, and it's very difficult to access that permission process. Now we can move on to some example that what exactly we can be supported as a academicians, as a researchers in the impact of the society in the terms of AI for the deep learning process. As you know that when you start the deep learning or the machine learning, obviously some people, they want to follow the traditional techniques, CNN, RNN, GAN process. So obviously we have to be plan for the first traditional techniques, then we can give you one by one of our input, what exactly we are updating in the terms of this traditional model to the new model process. When as a basics researchers, they start from the imaging techniques, either X-ray data or CT scan data or the MRI data. So they have 10,000, 20,000, or 50,000 data maximum. So that kind of small amount of data, if you want to execute in the deep learning or AI based algorithm structures, so obviously he first selected in the terms of CNN process, because it is easy to be fit for that particular techniques. And most of the of Indian environment or European environment of the CT scan data set, directly we can upload in the CNN model process. So this is one of the plus point for that. But day by day, the algorithms need to be upgraded in the terms of the techniques, what exactly the outcomes we are getting. Like we are getting the ECG data, EEG data. So that kind of huge number of time sequence data, when we want to upload in the CNN model, we are getting the first error. The space complexity and the time complexity is a difficult process. So that terms we have to be upgrade in the terms of CNN to the RNN model. After that, day by day, few hospitals, they have a single data centers. One small example, the Apple Hospital have the all over India, lots of different kind of data centers they create, and they have centralized data process. And as a researchers of Apollo environment, if you want to access any MRI data scan data, so automatically that file they will not allow to execute in any different kind of distributed system process. That means CNN or RNN default is distributed system, so they cannot allow to test it. So that cases we have to be use the different kind of environment that is provided by the GAN, so they can execute this process. So this is the way you can easily understand that how one researchers can be improved in the terms of CNN to RNN to GAN process in the different kind of environment, data accessibility, and the different kind of medical application process. Now I'll come to the demo, because if you execute some experiment data, it will be very easy to add up fit for the basics environment for that terms of medical sector in the AI process. One small example, that the two inputs, and we can get that basics output if it is one in the terms of input process. So we get that positive answers. These are small kind of experiment data or model you want to create. Then we can improve one by one size of the data set, then we can improve the prediction model and all the things. So if in this cases, if we use this particular basics input as a 00 011101111 process. So now we can move on in the part of this experimental process in the terms of this Google Colab and the Python platform. So this is the why it is very easy to access, because it is no need to install anything. It is free. Google Drive is available, and they can give the space to execute on the process. So if you want to create the first neural network of this small model, just we want to create the array process. First we fit for all the array in the process. one by one, like that 0 0 0 1 1 0 1 1, what exactly that we create that getting the sample process. Just we store one of the variable in the part of this input features. Before that we have to be install one library. It is very easy to be execute the process. Then you can store all the input as inside the array. Just I print the array to get the result that is match or not. We store the value. And what is the target? Our target is 0 and all 1. So we can create all the output the same way, target output. If I click, it is stored. So this is our that basics requirement of a model is ready. Now we want to fit for weighted value, we want to fit for the bias, sigmoid functions, and also we have to be reverse sigmoid, which is called the derivative of the sigmoid process, to be get that our prediction model fit for this small data set or not. Now we can use that bias is 0.3, then learning that obviously that 50% 0.5, then sigmoid find functions of this input, and then we can execute that reverse of this process, derivative of the sigmoid functions. After that we are trying to give that minimum 1000 2000 5000 10,000 time execution process to fit for the training process. This is to be executing in the part of the process. So what we will do, we will just default try to 10,000 epoch times to execute this process. For the feeding you have to be do this input weights plus bias. This is the basics logic of the all kind of that default that deep learning process. Then we have to be give that forward techniques and reverse engineering backward to calculate the error part. And we have to be check that if error is positive or negative, so then we can calculate the next level of the process. If it is negative, that means our process is getting a proper direction. If it is positive value or tends to 0, that means our model input or bias are not proper. Then we can calculate the derivative process, multiple derivative we have to be input and the output devices process, and update the weight value. And now the model is ready. We have to check one by one. If we give the input is 1 and 0, so if it is input is 1 and 0, output is 1. So now I will check that input is 1 and 0, what is the result is coming? 1 0 1 1 0 0. So all the testing process we will execute one by one. And the model value if more than 0.5, that means go up, that is called 1. If it is less than, it is called 0. So just to see 0.3, that means it is counted as a 0. 0.6 1 1 1. So output is coming 0 all 1. Now I can check output is 0 all 1. So that means what exactly we trying to create a neural network, a small data set only for the 2 input set of that 4 different kind of the combinations, and we got the output after training, after test of our weight value and the learning rate. What we predict that data giving the actual result what exactly we defined. So that means this basics model fit for next level of application. So now we can improve the number of inputs, number of size of the data set, and then we can check that next level of the applications. One of the small testing process that always we consider as a uh, basics fever or not. It's not COVID, it's just only for that sometimes the different kind of virus is affected in different region. So this is the basics for tested that suddenly your nose the smell is going out not, that your weight is losses or even too high gain or not, continuously runny nose and the body pain. So this is the basics for combinations most of the doctors they prescribe. Let's check for the 7 days or the 10 days data or the 5 days data, and then you can be define that yes you are addicted at the terms of the virus viral effect or not. It's not COVID but some basics viral test. uh, Basically if in European environment, if the temperature is changing midnight to early morning, so that durations maybe 1 a.m. to 5 a.m, these durations sometimes so cold and sometimes no snowfall. So this is the fluctuation done. So if the people they forgot to switch on the heating systems, next day they have these four basics problems. So most of the doctor blindly they will test it these four condition. So that is we have to create one algorithms to basics kind of checking that particular persons is under any positive of the viral affection or not. Same thing, we have this 1 2 3 4 different kind of variable combinations, and we have got the one thing. So what doctor they assign that if it is any two positive, maybe your body pain is there, loss of smell is there, so we have to go to the positive. So this is the way what exactly we are getting the result, that how the people can predict under the virus affected or not. Now I can move on this sample of that prediction process, that it is working or not. Same thing, we have to input the array as what exactly we define this. It depends on the speed of the process. I have to be terminate other programs. It is easy to be execute, otherwise the machine will be slow. I close the other programs. First we have to be define the array of this particular three combinations: 0 1 1 0 0 1 1 0 0. This same thing, just to copy paste 1 0 0 1, all the things. So this is the way we just give this particular combination the process. And same way we tested bias value, sigmoid function, derivative sigmoid functions. Then we have to feed the forward and the backward process, and we have to be execute the 5,000 times to test the trading the data set. So previous programs we execute that 10,000 times. We execute 10,000 time to fit the trading, but here the number of process is slightly bigger. So that's just we are giving the 5,000 process, because sometimes you have to fit that. Don't waste your energy if you create a model and that model not fit for this particular process. So this is the one of the uh, demand in day by day when you want to launch this software in the real time platform. Basically these small algorithms, what our students or we are doing, that we are converting the exe file, and through that government of Kosovo we have one platform. If you create one algorithms, send to them for the test, and they will forward to all the employee and all the citizenship in that particular Kosovo. They have to download and check these algorithms, they are virus affected or not. So this is the way we are tested this kind of real-time dataset process. So that means if it is more than 10,000 times, so it's the small mobile phone will be hot. It's too more energy will be required, the power consumption will be concept. So that means we don't try to go minimum 10,000. Sometimes some cases 5,000 is enough to get the result. So that is the our optimization technique process to minimize the systems. Just I want to execute that, then you can see that how it is working or not, and our prediction model to that actual data is coming properly or not. So same thing, we have to be execute all the input process, and this is our output process. And after that we just tested few process, not all the things. 0010, so 0010 what they want, 0010 last one, is a zero. So check it, 0010, it should be zero point 0.3, that means below of the 0.5, that means zero. That means our creating the model fit for this model also. That means that same what exactly executing the neural network model, same thing can fit for this process. Now we can go for some real-time data set. In European environment, the students from class 6 or 7 or maximum class 8, they started a huge smoking. Is a very disease in entire environment in European environment, and we have a big challenge to minimize the smoking addiction process. Suddenly last 2 years in European government, European Union, They send official email to all over the European countries that please try to check the diabetic effect in the smoking. So it's a huge relations to in the terms of smoking increasing, and parallelly the diabetic number of patients also increase. So one of my students, they create one of the data set of 37,000, because it's very difficult to cut the data also on the challenge. 37,000 data of the smoking and the diabetic patients. They have the one relations they want to fit for creating a basics neural network model. So before go for that part, we sent an official email to the government of India, Niman's hospitals, three conditions: that smoking, abscesses, and the exercise. So these three things, how it will be linked with your data set and the output measurement in the diabetic. So they approve this only three logics just to count this particular process. And obviously in the terms of more than 70 to 78% accuracy, you can got the patient is diabetic or not. Basically in the research papers, we can see that 99%, 98% accuracy of the diabetic prediction model. But realistic, when you want to launch algorithms for the particular environment in where I am living in the Kosovo, we launched this particular process, and we got 78% accuracy. The government is very happy because we don't have any other different kind of prediction model to execute here. So only 78% accuracy, they happy, and already 4 hospitals they execute our this particular model. So just I will execute once again to move on this diabetic prediction, and we can predict 10 to the power 23 seconds. So it's very less. Below 1 seconds we can execute that environment, that family members, that how many people they can under the diabetic survival or not. So same thing, we just give the input array of these combinations of that part, that process, that three parts: smoking, obesities, exercise, and the diabetic. And same thing, 0 1 0, like all the combinations we put, and what exactly that our array of the output model that is fixed for the process. After that, uh, we change slightly sigmoid functions bias value and in the terms of the weighted value, because this is our test state depends on the what type of data set we are executing and how we are process of day by day execution systems. And what we can see that this particular three properties is independent data set of the parameterize. So that shows no need to change the huge bias value. So these kind of features we are executing, that reasons no need to be changed that 10,000 times the execution process, and we minimize the cost of the evaluations of the execution process of that on these particular algorithms. Just we test it one sample 001. So what is the required 001? If it is that process, that diabetic is the negative. So if we give 001, our model is coming less than 0.5. So that means that our sigmoid function giving the proper result in the terms of this small model data set. So we need one positive also. Positive means we can see that 0 1 0. So just we change 0 1 0. If we execute these particular functions, obviously more than 0.5, that means it's considered as a 1. So this is, that means what exactly we create this particular model also they approve in these diabetic prediction techniques. So this is the way we are creating the small algorithms to fit for societal impact in the terms of collecting the data in where we are living or where exactly we are doing the practical base of work process. Now we can move on
Sir,
some.
sorry to interrupt. Can you share this file?
Yes,
Uh,
yes, yeah. Obviously, it's all the codings. I will share to that organizer. Don't worry. You can take from there all the codes.
okay, sir.
I will be execute another 10-20 sample example code also. Okay.
Okay.
Now we can move on that next level. Next level means now as if of academicians, we know that when we start a small research, it will be very difficult to execute in the terms of uh, techniques or the process, where we can start? So it's a common question. So as a academicians, as a students, where we can get the data set, or what type of model we can run from the steps one. So that we can start after 2 minutes. We have some hands-on activity in the terms of the process. I just request all of you, please go to this menti.com and give some code of, and one basics questions. You can see it, you can open by mobile phone or you can open by laptop, desktop, whatever, just a browser. Go to the menti.com, please give this code. One question is available. I think, hope you already experimented a lot of different kind of model in deep learning and the AI process. So which is you want? Because I want to understand that audience, what exactly they need. I want to give that kind of experimental data in the terms of their request or their requirement. So please, I request you, please go to the menti.com, and I can switch on from here also, I can see it. Please go to the menti.com and you can easily uh, see the one small questions. The code is 52747459. I'll just copy this link and I can give you this particular in the chat box also. Please go to the menti.com and you can easily switch on by laptop or desktop. Please click this and give this code 52747479. One people already reply, so I need minimum 50% people or 50 people can reply the answers. I just request you, please try to reply more. Go to the menti.com, give this code. One questions will be visible, depends on your experimental requirement. Just give the answers. Oh, it's very good. 11 people response, highly appreciate. Whatever exactly you have some different kind of problem statement, different kind of process you can execute. Please visit the menti.com. We have another 2 minutes time, and depends on your request, what exactly you want in your upcoming futures experiment data, which model you want to execute. Just give this particular process, select it, and then we can move on the next hands-on session activity process. I need slightly more participant. You have another 1 or 2 minutes time. I request you, please apply more.
Sir, please share the code, sir. Sir, please share the code.
52747479. 52747479. Please visit to the menti.com and the code is 52747479. Okay, what we can see that 49% people default their move on the CNN. Okay, it's very a very impactful research process in the terms of Asiatic environment, how the people they move on the AI start from the CNN. We'll come out some experiment data also that how we can change this mindset up to CNN to RNN to GAN process also. 20 people reply. I just need slightly more. I request you, please visit menti.com. The code is 52747479. You can see the screen. This is the visible. The code is 52747479. 22 people response. I needed slightly some more. Out of 22, 17 people reply. It's free environment. Don't worry. There is no, your data will be accessible to the other people. You can be just give your informations. Nothing is required. Just only one questions visible, that you can give this particular answer process. We can wait another 1 or 2 minutes, then we can move on the particular session process.
Oh,
53 it's CNN. So very less number of people is using the RNN. No problem. So after that, my sessions, you can easily move on in this particular direction process, that how it will be work is more effectively result in the terms of the techniques. 21 people reply. uh, I think we have 138 people participate. So I just request kindly reply this mentimeter.com or the menti.com. Please give the code 52747479. The code is this. I can wait another 1 minute, then we can move on the next part. Okay. What exactly this data projected to you, that default people start from that 52 target audience, they want the CNN, 30 only GAN and the 70 the RNN. Basically this is the process, what exactly the environmental or that what kind of data you are available, that data which purpose you are using. In Europe, we don't have any strict rules, but what kind of data, what kind of societal problem we are accessing, CNN we cannot use at all. So default we have to be move on, tested from that RNN, and then next level of the GAN. I will come out that one experiment data, that what exactly we are using uh, uh, our different kind of level of the research process. So one of that small video, that how that our students and our academic team of Rochester Institute of Technology, RIT Kosovo, we have one of the contribution in the terms of these particular medical sectors. First you see the video, then I will come out that what our contribution in this particular model.
This is not a doctor's office. It's Forward, the world's first AI doctor's office. It all starts with the CarePod, an entirely new approach to healthcare with prevention at its core. With health apps, your care team has the latest technology to treat the issues of today and prevent the issues of tomorrow. We'll start by establishing a baseline of your health, diving deep into all aspects of your health: past health history, current health state, future wellness goals, body scan, biometric monitoring, blood testing, and more. It's all about understanding where you are today, where you want to be, and how to get there. After establishing a baseline of your health, you are able to personalize your care with health apps built for you, like our Heart Health app, shown to lower blood pressure in 90 days. Powered by CarePod and at-home biometric monitoring, we'll be able to detect murmurs and other irregularities and help lower your risk of a heart attack or stroke. With the focus on keeping you healthy, you and your care team will be equipped to make the right decisions for your long-term health. Or our Skin Cancer Scan app, which enables you and your care team to track things like mole growth and skin lesions over time. Or our Mental Health app, to monitor anxiety and depression with ongoing guidance and support. Whether it's weight management, diabetes screening, or everyday care, like a routine blood draw, COVID-19 testing, or kidney and liver health, there's something for everyone. Because health isn't just about seeing a doctor when you're sick. It's about continuous, comprehensive care that addresses your health concerns today and prevents those of tomorrow. The world's first AI doctor's office. It's forward.
Okay, so basically, uh, in European environment, day by day, the number of doctors or number of, what I can say, that medical sector support team is very difficult to get. Is a huge demand, either nurse, either doctors, or the medical support team. So day by day, the people, they are trying to move on in AI doctor process, but it's really difficult to imagine that how it is possible to physical sectors to move on the AI sector. It's true. It's true because of how the AI can trustable in the part of the decision level sector process. But the question is, if you don't have anything, so you have to be move on the AI process. So this is the current situation of Europe. If you go for to purchase one paracetamol, you have to be go doctor appointment, doctor test it, after that prescribe, then you have to be go and purchase to get this paracetamol. So this is the 4 steps in European environment. It's not easy matter to get a paracetamol also. But in India is different structures. So these 4 steps, now the people of European environment, they want one support team to get the basics needs of the requirement of the health sectors. Like, we have diabetic patients, we have what I can say, high pressure patient, we have some skin disease, we have some different kind of eye disease. Sometimes the most of the people, they have that vitamin D lack of most of the European environment. Is a huge demand of vitamin D lack process. So this kind of basics requirement, if you go to the doctors, it's a huge process. So now the few first world country, already Netherlands and Germany and Poland, these 3 countries, they launch this pot. It's a very interesting system. The small box is there in the center. People will go, they will pay €2 to €3 by the card. They enter the particular box or the pot. They've dress the particular quality of that sensor using the dress process. After 25 minutes, they'll got all the report in the mobile phone. And it is a huge demand that Sunday, Saturday, people are going out for the family, and they have some 20 minutes to check the particular pot process, and they got the report. So this is the way they are people creating this care pot. And this my country now, current Kosovo, we have a different kind of pot. I'll be demonstrate that part also. And this kind of sectors that our students, they're creating the small algorithms depends on that particular data set. We launch in Poland. So Poland data set only we can use to test it the experiment process. And the Poland government, they allow us to use our algorithm for that particular pot process. It's easy to access, easy to be install our algorithm, this kind of environment, because it is available. So as our students, these particular sectors, one is that blood pressure control, and this if the people age is more than 35, suddenly they have the eye problems. So that kind of testing process, and the basic taste of tongue, because suddenly if European environment, people have one very common disease, they don't have taste of the food. So if it is too spicy, less spicy, or it is sour or the sweet, sometimes suddenly the man have no taste. That means they have some viral effect. So this kind of also it's a common disease in this in European environment process. So this kind of tested you can easily get within €2 to €3. You can spend and immediate report within half an hour got in your mobile phone. Another project is, it's also very interesting. It's near to the Germany border, in the process of the Poland, small city. One of the health sectors insurance company, they gave the project. basically in European environment, without health insurance you cannot survive, you cannot live also. Every people, they have to be health insurance, otherwise they're not allowed to enter that particular country process. The problem statements that maximum old age people are in Poland, and the old age people are frequently sick and fever, and if you go to the hospital treatment, come back, everything is under the insurance company, and it's too much increasing the bill. So they put the open problem statement, and lot of company, lot of team, they visited that particular area, and me and our team also, we went with our students. What we observe, these particular cities, the city name is Ostrova. Every building a smart house, because they are in that level, that everything controlled by the mobile phone or the IoT device. Either it is washing machine, it is the refrigerators, open the door, close the door, open the garage, everything. And because the family members are living in the big city, and they want to observe their old age people in that particular smart house, easy to manage, easy to observations. So this is every device under the part of this particular process. Then what we observe with our team, we stay there 17 to 18 days, that every house, they have different kind of IoT device, but the hacker, they control the air condition data in the midnight, 11 a.m., 11 p.m. to 3 a.m. or 4 a.m. This particular data pattern we observe, and that automatically the air condition data is in minimize, because all the IoT device are in stored in the cloud. So cloud data, anyone can hack, is very easiest way, if not that is toughest problem. And they are minimizing the air condition data, so the old age people, they don't have a time or energy to check the air condition temperature in the midnight. They are sleepy mode, and next day morning, due to the temperature minimize, they are sick and they have to call the ambulance. So this is the different kind of problem statement is coming. That how deep learning solve this? Yes, we extract the data pattern, that what exactly the particular process of different kind of IoT device data we extract. What we observe, the data are the same kind of changing the particular time. That prediction analysis, and we convert the automation system to the manual. We remove all the IoT device of the air condition process, which can more affect the temperature techniques. We remove all that automatic systems, IoT device, we change it is manually. We fixed a persons who can control entire house manually, not at all the automation process. And from this process, we converted, and that next 3 to 4 months, we observe that yes, that old age people of that particular society is less number of sick going on. And couple of months, we are receiving the good impact of the process from that old age people. They are so happy, and they are sending us the appreciation letters. And now our project is that another 2 years continuation process to observations of that medical sector data of what exactly they are using. So don't think that your data or AI or deep learning can support exactly the medical instrument process. Sometimes the environmental data also can support a bigger way in the medical sector. So this is the one of the project what exactly we experimented a different way, and we converted the different technique process. Now, how we can convert in these challenges in the terms of theoretical concept? Obviously, the first process is the data considerations. Is the data set is from the rare disease? No, because this data is coming from the air condition data. And now we have the first questions, this data, it is clean data or not? How you can prepare this data fit for your machine learning or deep learning algorithm process? So we have two stages. One is that data set challenges, next data preparation steps. If data is clean or noisy, we have to remove that process. After that, we have to use the standardized normalization technique for scaling all the numerical features in a normal platform. So this is the another advantage of all medical sector research. You can use default. Second thing is that now the techniques. or what kind of advanced process of the normalizations can be done by non-medical sector data to medical sector data. Three things is there just to check your F1 score. If it is too much high, obviously your data have lot of noisy data or unclean data set you have. If F1 score is minimized, tends to 1, like that correlation coefficient process, it will be going to be 1. And another two thing is there, that balance sensitivity specificity of the upper limit and the lower limit. You have to be check the ROC, AUC, and that precision recall curve process. So this is, I'll come some experiment, some coding I'll showcase you, that you can easily understand that how data set to be minimized these three normalization technique to access the non-medical sector data in the terms of medical sector process. Very simple thing, just you have to be define some structured data set first. What I told you previously, that you start from the small data set, then you increase the number of data sets slowly. Similarly, first we can start a structured data set that is fully clean, that one prediction model of the hospitals we can split in three different level: patients level, visit level, event level. It's very interesting structures. Every hospital of European they are following. One patient came to the hospitals, they gave their informations, name, address, phone number. Automatically the hospitals and the government, they have the centralized systems. They automatically check this patient visit which hospital before or not. That means if a patient visits same disease before any hospital, that data new hospitals they can easily access. So this is plus point of this European environment process. And second thing, what type of diagnosis they did previously and what current stage is required for the diagnosis. So these three process current situations we can predict and procedure by the AI environment process. So this way, the European medical sectors, most of the hospitals they are following, because we don't have that much number of doctors, that much number of patients. So we have to dependency in the terms of AI process. Now I come out some depthly in the terms of three different categories. Either you go for the CNN or RNN or the GAN process. Obviously, it's the very basic things. Every CNN have that convolutions layer, ReLU, pooling layer, dense layer, and dropout. This is the major factors of you can execute all the process of CNN techniques. Now the question is, how much size you have to be start for the filter, either 3x3, either 5x5. If it is huge data set you have, either 15 lakhs, 30 lakhs of the data set you have, don't waste your time, directly go for the 5x5 filter size. If you have very less number of data sets below 10,000, go for 3x3. So this is the way you can train your convolution layer. Second part is that sometimes you have to be restricted few filter in the terms of linear unit process. So this is the one of the addition techniques you have to be used in the terms of convolution layer, which purpose your pooling layer cannot fit for your algorithms. That cases what you will do, just change your maximum value 0.5 to 0.7. We don't know why, but when we change this value, automatically we got the good result. Basically we tested the depends on the which data set the maximum pooling layer or maximum pooling value, how much we can change. We can change 0.5, 0.1, 0.5, 0.2, like that. We increase one by one and we check 0.5 to 0.7 is the maximum value we can get it. And finally the dropout. So if you follow these basic steps, automatically your CNN model can give a better result in the terms of imaging. That means you have the cancer cell data image or MRI scan data image. So these two things you can easily get it. The two part, as I told, that European environment have that skin disease more, skin cancers more, because we don't have the vitamin D directly sunlight to the skin. So always we tested these kind of cases, the age, texture on the patterns. So three major factors default CNN can support. So automatically that as a students or researchers, they can directly move on the skin disease techniques in the CNN model process. This is the one of that sample code. Obviously, I will execute in the terms of hard disease predictions. First, I execute, then I can come out. The experiment is very easy, and basically one of the real time data we collect a couple of year from 2017 to 2021. These durations we collect a couple of that real-time data set. Is not that any agency or any government sector they visit the people and they collect. No, we have exactly the few doctors who have real-time patients and they happily collaborate with our research, and we got this particular data set. And we have a couple of very strong clean 1026 patients. That is the different kind of age, different kind of level of the heart disease. So what just we have to be execute in the terms of prediction process. So Google Colab, obviously if they cannot save your data set, first you have to be upload data set. Just to click the left side and you can have the option for the upload. Just to click these symbols and you have that particular folder and you can upload this data. It's take 1 or 2 minutes time, depends on the internet speed. Just you copy the path because I have to be, otherwise it will be error. So I just change the path, so it is very easy. Control V, delete. Yes. So same thing, we have to create one standardized algorithm process. We not tell that CNN, GNN or RNN process. That is default, we will do later, depends on the problem statements. Just I want to fit for these particular basics algorithms, that how it will be work. Just I call this data set first, and it's a huge number of 1025 rows are there. And first we check that what kind of header that means are available, and it is clean data set or not. If it is not clean data set, you have to be check that particular process. Then we have to be install the keras. So this is the one of the features we need, because sometimes the all kind of Python package default they access all kind of model. So this is our advantage. That's just I always install this. Sometimes you don't like, so you don't want, but I love this particular platform to execute this kind of things. Default they can support the functions. Otherwise we have to be design the functions process. And I define the model of default 80% 20% tested training, but I converted that 74 and 26. So that is our strongly upgrade model what we use. And we check the different kind of parameters that our model can predict the disease or not. And we also tested the confusion matrix, that if it is diagonal is one is coming or not. So this kind of tested we did, we already check it, and all the cases we got that very effective result. And I told the F1 score is it is 1, that means you are the standardized norms of that. So but this model we've launched in Kosovo government medical sectors, and currently we have this is very small country, so we have only 28 patients now under observations of this particular model. What X-ray doctor prescribe, and the AI doctor they can give that prescriptions from their current stage. So hope upcoming we can get that more accuracy, more number of patients, so then our training data set will be increased, and we can easily get that highest gate of the result process. So this is also that part of the CNN model, that 4 categories, that obviously we converted first that convolutional 2D layer, then max pooling. After that we use that 1D vector sector for the dense layer, then we convert the dense layer drop layer, and finally you got the output. So this is the 4 categories split in this normal CNN of the heart disease prediction model. And we got slightly good result of 82% accuracy, and expected that within 2 to 3 years we will get that more number of patients in the Kosovo environment, and then we can move on that real-time implementations in that more than accuracy in the part of this prediction model process. So what is the advantage? CNN, obviously, as you saw that you can see in the here that once again that see 53 people are in the part of the CNN. So obviously that they have some advantage, they have easy to access, so that's when they are using this particular process. But in the technical terms, that if you have imaging type of the research process, it's you can say that without manual engineering, that means some machines they generate the medical sector report like X-ray and CT scan, is the best to fit for your CNN model in their platform. Basically, I know that in the Asiatic environment, it's not easy to install your algorithms to particular hospitals. They will not approve you at all, and they will not allow you to test it your algorithms directly in their hardware device. But in European environment, we have options in our research lab. Our college, they are providing to creating the big infrastructures in the terms of testing the hardware devices with the software process. Just we send our algorithms, we have a team, they are installing, and directly they will test it in the hospital. So before got the approval of the government sectors, they can test 2-3 times. If it is effective result coming, then they will apply for the approval. So this is the way we are working. It's not good way to be tested, but we don't have any other options. Directly we are saying that it's the only solution to be tested our algo in the directly hardware devices process. One scalability options also is required, and it is the important part of that. CNN default, you can use small and the large data set. So other algorithms, they can get that F1 score changing 10:1, not 1 will come if it is a small data set, or that not clean data set will be available. So that scalability is CNN is the plus point. So that's always we are telling our students that default you try to move on in the terms of CNN process. Next, one experimental project, what exactly we are doing is very interesting. As you know that the women or the girls, they loves to wear the pencil heel in European environment. Default 99% working women, they are wearing the pencil heel morning 8 a.m. to 10 p.m. So it's a common, depends on their style, depends on their requirement, societal impact, leave it that part. But the question is, if you wear the pencil heel this much continuous 3 to 4 years, 5 years, you have the very difficult orthopedic problems. So you cannot walk normally. You can see the right side corner, the women have some orthopedic problems, and if you are walk normally, left side one cartoons is moving on. So this is the way it will be work. So what exactly our project is, European environment, every city they have a center, and the mayor of my current company, my current country, they put a camera in the center. If the woman or girl not walking properly, they mark as a red color, and if you are walking normally, they put as a blue color. If you are not walk normally, they send the SMS, maybe you need orthopedic help. So mayor send this message, because we have everything data process of your face detections to data phone number. It's very easy to extract, because less number of people, the government have observed everything, government follow every records, so they know that where you are moving. So it's not that much difficult job to send a one SMS after the face detections. So what this project did is, the mayor launch the camera in the center, detect the red color, and send the message, you need the orthopedic support if you are walking abnormal, and the mayor win the match in last elections because of this project. So what we did that we create a data set how girls can walk with the 8 different points, and from that particular points we converted a normal GNN model, because it's so fast we need to be execute, otherwise very difficult to process. Within 3 to 4 seconds they need to be send the SMS, so that's why we use GNN model. And we tell that particular patient is not properly walking, so you need to be send a SMS that maybe he need or she needs that support. So this is the project, and how we can convert that techniques. That first we converted the PyTorch CNN. So it's slightly modification part what we did inside the GNN process. Obviously that rectified linear unit, we change different kind of layer process. Just to see here in the diagrams, input, convolution layer, pooling, and the fully connected. So this is our modification part, the normal CNN to this different kind of vertical convolution data of that one people when they're walking, the 8 points data we store, and we run minimum 30 to 55,000 times epoch. This is the numbers to get the solutions of train that particular city data. So this is the way we are converting the modification of CNN of this particular project process. After we success of this particular project, the government they increase our funding, and we now converted a device. So this is the one of the very interesting project. Last couple of year, me and our team, they're working closely on these particular things, and it's very difficult to get the approval to launch this product. But soon we will launch in India first, in Bangalore and Chennai. We will launch these 2 products. First to see this small video, then we will explain that what exactly that our contribution in the research in the terms of this, and how we can be benefited in the Asiatic environment. People can be fit for this tested process.
When you come to an Eco Health Center, the first thing that happens is that you get checked in by one of our operators. Throughout the entire scan, you'll be together with the operator, who's a trained medical professional, and you'll also meet a doctor who will review and discuss the results with you. And the scanning starts with a standing up scan, and we take high resolution photographs of every inch of your body. This allows us to create a reference image of your whole body. So the entire scan takes about 20 seconds. At the end of the 20 seconds, we have every inch of the outside of your body. We have your entire shape of your body mapped out, together with a temperature profile of your entire body. The second part of the scan is you go over and you lay down on a bed. There we do a cardiovascular assessment, where we measure how your heart is beating and pumping blood, and how that blood is moving through your entire arterial tree. We measure the pulse at 7 different locations throughout your body to understand its shape. And this enables us to do a much better characterization of the health of not just your heart, but your entire arterial tree. Then we check your microcirculation. These are the smallest blood vessels in your body, and we assess their capacity to supply your cells with what they need. It is believed that issues with these vessels are a common starting point for disease development. So after that part of the scan, we take a simple blood draw, where we check for essential blood tests that we process on site. The second part of the visit is going into the debrief room with the doctor. You spend about 10 minutes in the scanning room, and when you meet the doctor, all of your results are already fully computed, calculated, including the essential blood tests that we've done. So the entire session is just for you to talk with the doctor, to go through all of the results. And we do it in a very different way from a traditional doctor's office, where there's no desk, there's no keyboard, there's just a big screen with an avatar of you, with all of your health information mapped onto this avatar, and a doctor to walk you through every step of how to interpret that data.
Okay, so basically previous project is fully AI doctors, because we don't have any kind of infrastructures in the Europe. So that means we fully depends on AI. But when we want to launch the product in Asiatic environment, we have some AI trust issue. It's not easy to be adopted. That means we install two persons inside the AI device. One is that normal nurse, and one is the expertise, like medicine doctors. So then we fit for same product we are launching in India. So hopefully if, Indian government they approve our process. We are in ongoing techniques. It's different team they are working on that. So NECO, this is the first like that pot, that AI pot will launch in that Bangalore 2 and the Chennai 2. If it is approved, then we can move on. The every city will launch this one. So this is that World Bank supported this project, so it's a good impact for societal things, because day by day the number of population is so much increase in India, and that medical sector support, they need the automatic prediction process. So this is on this kind of pot, maybe some city few people they will get easily get the result in the terms of their healthcare process system. So this is the way we are trying to connect it with Asiatic environment to this European environment. Two different sectors, same kind of the process, and two different company they are trying to launch. So this company, our students, as it is that only this we have Kosovo data set and Kosovo societal problems. So we have only the two part. One is that dentist, dental issues, or any kind of disease in the part of dentist, and the skin. So these two part is our project involved in these particular sectors, and we are creating the different kind of accuracy prediction model process. So this is our target to be moved improvement. Hope in India we can get more number of data set, more number of patients data, then we can train it, and automatically it will be next level of prediction process. And again we come back in the European environment to launch that upgrade algorithm process. So this is our main agenda of the process technique. Now, so this particular NECO, we are not default move on that CNN. So we have to be change the slightly modification of RNN model for two process. One is that dental informations of the disease, and the skincare process. So here the three major part. One is that GRU, gated recurrent unit, LSTM, long short term memory, and that by RNN. So these three factors, we are changing different kind of parameters and prediction process in the terms of conjugation techniques process. Basically sometimes one layer, or there is no layer at all, we use for the really when directly we connect the dropout process, but we here use minimum two layers. So this is the our advantage of getting the accuracy level. So this is the process we are trying to improve in the terms of techniques. The four different parameters which we modified, and depends on the data set, we are access of particular strict value, hidden size, epoch, seed, and the class weight. So these four, if we control properly, the RNN model is the best for this type of data set process. So this is that one of that basics requirement techniques of the RNN process. I'll come out that one demo, then we can move on that basic process. I just see that one of that standardized model, because sometimes that RNN, when we execute that, suddenly our GPU machine is collapsed because it's really required the huge number of memory shortage process. So that's we are trying to showcase you the same kind of idea inside the CNN. So this is that one of that interesting process, because sometimes if we not get the actual RNN data, RNN model, so same thing we are installing inside the CNN. So this is the one example, and same thing will be happen because of the we tested the both different process as we are executing in the terms of that Google Colab. So RNN slightly 15 to 25 to 30 minutes required to execute, so we don't want to waste that much time. Just we convert same concept in the CNN, and we use the small data set, we execute 3 to 4 seconds. So this is the reasons we design this kind of process. So basically, if you create, this is the basics model, and I'll give this code just to change your data set and the model parameter what I told in the RNN. So if you converted this process, then your entire RNN can be fit inside that model. So this is the plus point. So don't worry, I'll just first to execute this code, and I'll just explain that how the CNN data features can work. Just I stop the previous, otherwise my memory will be gone. Yes, just close. Now I can execute. Just to see its execution time, 3 seconds, 4, 5, 6 seconds is required CNN. But if you want to execute same thing in RNN, if minimum 25 minutes. So just I off that part and I execute here. So what, same thing, that one configuration layer, second configuration layer, third layer. So these 3 layer, basically what we did the first 2 part. So this is the conversion of RNN CNN relations between these. After that, we use that connected layer and output layer. So these 2 data, we are connected with these 2 layer. So that means this entire RNN we can execute because of the time complexity and the accuracy process of small data set in the CNN library process. And how we can accept your idea. Okay, now we just print the model. So just we just print the model, and we can see that how much output shape the parameters are used in this inside the each functions. So COVID 2D, max pooling data, conversion 2D model, dense, flattens, max, all data we printed, and we check that is exactly the same value of RNN produce, and this CNN also can produce. So this is the way we are executing the same features, same particular the RNN features in the terms of that particular technical process. So this is the way of executions that RNN can be fit a particular specific data set inside the CNN process. So this is the way we are executing this. So all the code I will provide to you, don't worry with the process. So now we have some knowledge of CNN, we have some knowledge of RNN. We have
Sir, 1 minute. Can you show the previous slide? I want to note down. Just 1 minute.
this one.
Before this. Before this.
This one.
Before this, sir. Yes. Wait, sir. 1 minute. No, next, sir. This one, sir. Wait.
This one.
Yes, sir.
Is this visible to you? Now okay. Or I can give this PPT to the organizer. They can share this PPT to all the people. Don't worry. Okay.
Yes, sir. Yes. You please share. Thank you.
Yes. Now you have some idea about the process of experimental data in the real-time problems. But the question is, what is the futures that which way move on in the AI researchers? As European environment have the different societal problems, and here research is move on to solve only societal problems. We don't have that publication base or that printing base. If you observe that last couple of years, the COVID, if you search the COVID-19, I think more than 50 billions research papers available in the Asiatic environment, but how many vaccines are available in that process? So exactly that opposite in the European environment, they only want your idea how to solve societal problems. So what we observe that upcoming AI move on these two directions. One is that quantum AI and the edge AI. So one thing is that day by day, you have to be improve your in number of convolutions model, and it's so costly. It's day by day huge power consumption required, and when it is more power consumption required, it takes huge time. So these two things they want to minimize, and they one kind of research team they move on the quantum process, quantum AI. And one of the techniques process, no, we don't care about the time, we don't care about the cost, we care about the accuracy level. So they move the HAI. So if your idea of any societal problems, European environment, if you want to be move on to give some solutions, you can be approach your choice in two directions. If you want to submit some proposal, research collaboration, research proposals, funding is the European environment of the huge funding opportunities. So if your idea move on these two kind of approaches, obviously your idea will be easily acceptable process. Before close the sessions or before go to the discussion for last 10 minutes, 20 minutes, one small example. I met Mozilla Firefox director. I think a lot of people, they are using the Mozilla Firefox. So in the Docotech is the one of the biggest platform in the European environment. And I met with her in that particular conference. And next year, I'm in the stage in my convolutional research process. So she told that she create the entire Mozilla Firefox AI concept from the Indian Hollywood. So when I was in India, really I don't know that Indian culture, Indian inspiration is so much demand in European environment. But after coming here, I really surprised at how the people blindly follow the lots of Indian techniques, Indian spiritual algorithms in the terms of different kind of Hollywoods. So it's very easy to impact, because always when me and my team, we are trying to create some algorithms, we always compare the Indian prospective Indian data set, Indian disease, Indian different kind of doctors recommendations, then we are trying to launch here. So obviously it's a huge impact, research impact we can get from the Indian environment. So it's very easy to open your eye to your own cultures, and easily you can get the new kind of AI sectors solutions in the medical process. Thank you the organizing team to giving me the platform to showcase my research, all the things. We can come out some discussions in coming 10 minutes, depends on your questions or in the terms of chat box queries.
Yes, sir. Sir,
I can stop sharing. Yes.
I have a doubt that in CNN, whether every convolution process is to be followed by the max pooling, or max pooling can be skipped.
We are avoiding both. Okay, so we don't want to use at all in the max pooling process till now, because here data set is fully non-correlated, so independent data set. So if the data set is fully independent, so we don't want to go directly the max pooling process. So that part we trying to avoid default to go for the CNN techniques.
And sir, why the filters are of size 3x3 or 5x5? Why not any other numbers like 2x2?
Okay. So basically, if you start from one point, so that point nearby odd value is 3, 5, 7, 9. If you increase the more 5 cross more than 7 cross 7, it will be huge time complexity, because left to right or right to left convocation way, they can check all the data set. So 3 cross 3 is the small box to check entire data, not to missing the edge part also. Clear my point? So if it is 7 cross 7 or 9 cross 9, so that means you have to be change the edge side 336 layer we are missing. So that kind of non-missing data set, if you want to convert, so start the small size of the convocation layer 3 cross 3 or 5 cross 5. If it is more, you have to be delete or ignore the edge part of your data set.
Sir,
Yes.
Yes.
we can go for padding, na?
Padding is how much accuracy? 50%, 60%. Okay, so there is no algorithm available in the padding is that more than 80% accuracy.
Okay, thank you. Sir,
So this is also one of the huge research scope. If you have tried to create a unique padding algorithms which can give them more than 50% accuracy, it will be very good, perfect.
Sir, good evening, sir. Actually, I have doing a work on hardware security purpose. So,
Okay.
for how we can interpret into the AI or machine learning, sir?
No, basically AI agent is different. AI agent means you are predefined some algorithms and the instructions given they are follow. So security every time, day by day, they are upgrading. So AI agent cannot support that part. So my solution in the security sector in the AI, that you have to be try to minimize the number of hardware connectivity. Very simple thing. I am talking with the laptop. So that means only this laptop can be accessed or hacked by you, but we cannot access by the mobile phone, because this is my without internet now it is available. So that means it is only solutions if you have disconnectivity of the hardware devices with the single network. If you have the multiple different network, it's very difficult to hack, very difficult to access of AI protection process. You have 4 devices, try to connect the 4 different internet process, so it's impossible to hack.
Thank you, sir.
Sir,
Good question. Yes, ma'am.
sir, we are having suppose 227 by 227 image with 3 channels, and we applying mask 3 by 3 mask, and that is of 96 mask filters, we can say. So how that communication will happen?
Okay,
How this
so
will be applied?
if you want to do the only communication part, you just forgot how many masks you have. Maybe sometimes you have more than 100, more than 50. It's different. Just to think that you have the only 10 mask. So
Okay.
that communications is very easiest way to create the LSTM, long short-term memory techniques, to save each mask centralized value. And if the centralized value is odd, create one algorithm. If centralized value is even, create another algorithm. So just if else. So this way they can connect and give the single solutions.
Okay, sir. Thank you.
Very good question, ma'am. Thank you. Any other queries?
Sir, can you suggest any deep learning techniques which are used for research point? Because all these models, pre-trained model or even CNN, RNN, they are existing. But if you want to make some improvements in them or develop our own model, then what can be there for? What can be done in that sense?
No, basically, if you want to start your own research, you can start from these 3 basic things: CNN, RNN, GAN. After that, you try to update the parameter first. Next level, try to update the layer. Next level, try to update the each output recall value. So these 4 things, if you create, automatically it is a new algorithms. Basically, when you want to create a normal code, but that code, if you want to install in the hardware, is a huge difference result. Clear my point? So that is just always try to check that what type of hardware compatibility you have, and that module or that parameters you try to update. So this is the only solutions. Otherwise, you cannot get the actual result with respect to your mathematical implement in the algorithms. There's a huge difference happen.
What is differential CNN? Differential CNN.
No, differential CNN basically it's you can say that regressions analysis without correlations. So this is that, because sometimes you have the huge number of data set, you cannot calculate the correlations, you dependency on the regression analysis. So that kind of cases that you cannot execute the CNN, you have to be execute that kind of CNN. Basically, if you see that big data set, that left side diagonal value all are odd, most of the values is odd. So this is the easiest way to you can check that which data set you can use the normal CNN or the classical CNN.
Hello, sir. What is the use of that reverse sigmoid function used in the first program?
You just one common thing. You have three values. So obviously the middle value we can compare is the median. Okay. Now just to increase the number of slot, 3, 5, 7 until 1000, 10,000. So it's very difficult to put the middle part in the median value. So that cases we have to be use the different kind of sigmoid functions to predict the bias or weighted this difference. So these cases we have to use this particular process. The calculate the value bias minus weight value.
Thank you, sir.
Yes. One
Can you
question
share your
came in the
ID?
chat box. In
Email
India, we face the problem of getting patients real-time data. Any help for this? Okay, Kavita ma'am, it's true. Basically, for that you have to be need good connection in the doctors or good connection in the data center people. So if you have some student or some colleagues, they are working in the data center of that particular hospitals, they can give you the real-time data set. So I create with the 5 years relation connections collaboration. So now they trust me and they can give me for this kind of real-time patients data of Indian perspectives. Yes, ma'am.
Sir, please share your email ID.
Okay, I will just give my informations, no problem. I just give all the data, all the PPT to the organizer, and they can share to the all the audience. Anytime if you need some kind of coding or any kind of experimental process, obviously I happy to help you. So thank you for these collaborations and interesting questions in the terms of.
So your voice is muted.
Stop sharing. Yes, am I audible now?
Yes, sir.
Yes. So basically, whenever you want to, because every day by day we have a team who are working process or execution techniques. So just follow my LinkedIn, and there a lot of latest research process will be available there. I just put in the chat box. You can go through there, and in the terms of the email ID, the queries, you can feel free to discuss with me. Depends on your interest. I just submit my email ID also there in the chat box. You can find out from there. Okay. Thank you for the audience. I really appreciate that organizer, that ATAL and ATAL FDP, and there is more than 150 participants. It's very good. It's a very good connectivity in the terms of that accessibility. Thank you all. We'll
Any
keep
other
in touch with
queries?
such kind of things. You can feel free to discuss with me.
Any other queries? Okay. Sir, on behalf of the organizing committee, I, Abhishek Mishra, would like to extend our deepest gratitude to Dr. Samanta for sharing his valuable knowledge and insights with us today. Your session on indirect disciplinary research, deep learning, blockchain, and image processing was both enlightening and inspiring. The depth of your experience and the breadth of your work have undoubtedly broadened our understanding and provide us with a new perspective on current trends and research and development. We are truly fortunate to have had the opportunity to learn from some with such a remarkable academic and professional background. Your contribution to the field of computer science and engineering are commendable, and we are grateful for the time and effort you dedicated to this season. We would also like to thank all the participants for their active involvement and engagement through the session. Once again, thank you, Dr. Samant, for the presence and for making this FDP session enriching and experience for all of us. Thank you, sir.
Thank you all. Bye. Good night.
Good night, sir.